This is the second in a series of videos in which I'm demonstrating the use of a CNC winding machine. But before I get into this video, I just wanted to cover off a comment that was made on a previous video, and it relates to this device that I showed in a video that I'm making on rewinding a toroidal transformer. This is just a drop-in replacement for a bridge rectifier, but has a much lower forward voltage. I did show this in the video and I showed how it was wired up, but a comment was asked saying it would be useful if I showed how it was connected. I thought I had done that, but it's wired just as a basic bridge rectifier, so it's wired as this circuit. The only difference here that you can either wire it as a single diode. These are dual diodes. You can either use them as single diodes or as dual diodes. What I've done is to cut down on the forward voltage at higher currents is I've wired the two diodes in parallel. So they're actually wired like this. So, and the same with these two. How you physically connect them is entirely up to you. It's down to the individual as to what space you have and how you want to make the interconnections. The spec sheet just does show the pin out, so you can connect them how you want to, but just as a close-up to show how I've implemented these connections. This is not the only way of doing it. As I've said many times on my videos, I'm just offering advice. You can either take the advice or leave it. This is just one of many ways that this could be implemented. And you don't need to use this type of device. As I said in the video, you can use any diode with a low forward voltage drop. And so that's it. It's just a bridge rectifier, and it's wired up exactly as per the diagram that I showed in the video. Okay, so onto the CNC winding machine. In the first video I showed how to do some very basic simple winding, sort of linear winding, and the machine is very useful for that. As you saw, it can create windings at very high speed. It's very efficient, especially when using fine wire. But where it really comes into its own is when you have specialist types of winding, because that particular machine and the software will support scripting. So in this video I'm going to show wave winding. Now this is not to be confused with wave winding in motors and generators. This is wave winding that's used to generate very low or windings with very low interwinding capacitance, and that type of winding is most often used in high voltage generation or in RF applications where you don't want a lot of capacitance in the coil. So in a standard coil, then all the conductors are laid down side by side. So although they're at a slight angle, they're effectively all laying alongside each other, and that means you get a lot of capacitance between the individual wires. And if you're trying to generate high voltage, of course, that means that a lot of the energy you're trying to generate is going into this capacitance, and it cuts down the peak output, if you like, of your coil. Or if it's part of an RF circuit, then obviously this will have a major impact on the goodness factor of your coil. So quite often it's beneficial if you can wind the coil in such a way that you're not laying the individual conductors alongside each other. And one method of doing that is wave winding. So if you imagine if you were to lay the coil out, so although it's round, of course, you could represent it as a linear set of windings. And the way that it's wound is the conductors are moved across the surfaces of the coil from side to side. So they're wound like that. The next conductor can either be wound ahead of or after the previous conductor. I tend to wind them ahead of, that is forward of, the previous conductor. And so the next one would be wound like this. It would step over the previous winding, so it helps to hold this winding down, and then it moves across and goes over this winding to hold that winding down. and then they continue in that fashion. So the next one would come along and it would be wound like this. Now of course this is in a coil, so it is wrapped around the former, but each time you put a layer on, then that holds down the layer underneath. So we'll demonstrate this on the machine. Like I said, this is really used in specialist coils, RF coils, some line outputs, transformers use this method, and it's found a lot in old equipment, and I do restore a lot of vintage equipment, so I tend to use this technique quite a lot. So we'll go over to the machine and we'll see how this works in practice, and I'll show you how to program the machine to generate a wave wind. Okay, so the rest of the machine is the same as you saw in the previous video, so I'm zoomed into the important bit. Now this machine won't do wave winding direct from the factory. This is a modification I've made to the machine. So you need to make a wave winding head, because the action of laying down the wire in a wave wound coil, if you were to just try to use the standard nozzles, then the tendency is for the waves to be pulled straight, and so they'd be pulled off each other and you just end up with a tangled mess. So what you need to do is make an adapter like this, and the way this works is, it's a bit difficult to explain, but when the coil turns it puts a tension on the wire, and because the wire is going around this curved former and then through a guide, the wire is being, at this point, is being pulled down towards the center line of the former, and that means that the if you like, the moment of force at this point is down towards the former itself, which means this arm is pulled downwards in proportion to the amount of tension in the wire, and it's then effectively held down in place by this small loop guide. So it's quite smooth on the underside to make sure it doesn't snag and catch, but it also guides the wire very precisely into place, but also at the same time it kind of pushes it down into the former, and that tension is largely self-correcting because it's controlled in part by the tension of the wire, which is coming down through here. I'm not quite sure if you can see it, but the wire comes down here around a groove in this former, down through the guide, and then on and round the former itself. And I've made this adjustable, but you set it up such that the wire is being guided onto the former, and then effectively it's like resting your finger on top to press it down in place, but modifying the pressure depending on the tension. So if the former's not perfectly round, then it doesn't matter. This is not rigidly fixed. This is actually pivoted. This is a pivot bearing where it's mounted on the machine. So if I move this, you'll see it's quite free to pivot at this point, and that means it can not only track any movement in the former as it rotates, so if the former is not perfectly round then it will obviously follow it, but also as the coil grows, then this can move up, and it keeps the wire being correctly pressed onto the coil as it's formed. There's not a lot of tension in this, it doesn't need a lot. It's just really a balancing between the force required to hold the wire down and making sure that it's not pulled so tightly that this wave we're trying to put into it is pulled straight. And then there's a counterbalance weight on the back to make sure that that balancing force created by the wire is at a reasonable level and can be properly controlled without needing too little or too much wire tension. So I hope that made sense. It's easier to watch it working than it is to explain how it works. So we'll have a quick look at the software to see how it's programmed, because obviously what we need to do is, as the bobbin rotates, we need to move the wire head across quite rapidly. Before we were moving across each revolution of the bobbin, moved the wire head across the diameter of the wire. But now we need to move across the width of the coil itself every half turn, in this case, of the bobbin. In fact, it's not quite half a turn. If it was half a turn exactly, then obviously each layer would be overwound on top of the previous one. In my case, it's slightly more than half a turn, and that means that each successive coil that's laid down, each successive loop, is stepped forward a little bit, as I showed on the diagram. So we'll look at the software. So looking at the software, you can't really use the standard mode for winding this type of coil, but this particular machine comes with a scripting engine. So if you change to the scripting engine, you can see that what we've got here is the script that I've written specifically for this particular coil. And the way that you write scripts on this, like I said, this is not a full review of this software. If you want me to do that, then let me know. But what you essentially do to set this script up is you would add a start loop, and the start loop, this is like a for loop in C, where this is the count of iterations you want through the loop. And so you enter the number of turns that you want, and this will kind of depend on whether or not you're going to do single waves per turn or multiple waves per turn, or whatever you want to do. You'll just set it up so that you have the right number of iterations through your script loop. So in my case, I'm doing 1 wave per turn, so I just set this to the number of turns that I want on the coil. You add that, click on add, and you'll get this, and you can see I've set it for 1000 turns. You then need to enter the parameters you want for the wind. In this case, it's for each half wave. So because I need the waves to progress around the coil as it's wound and not all be overlaid in the same positions each time, then you need to put a value in here. So I'll just enter a value. So if I put in 182, for example, you can see that there are some limitations with the machine as to the values it can accept, and this is just because of the resolution between the two motors on the system. And so the nearest we can get to 182 is 181.8, and that's the degrees it will turn for the movement that we're going to set. So in this case, if we decide we want a coil width of say 5 millimeters, then we would enter the coil width here of 5 millimeters. So you'd enter 5, and then you'd get the next line showing in the script. So you can see here that we have a width of 5 millimeters, and we have an angular rotation of 181.8 degrees. And this is just the speed that you set, so you can change the speed that each step takes. You can also set ramping, etc., which if you're doing a professional coil, then you would set it to ramp, because that gives you a neater finish and it's less likely to pull the turns off the coil as it develops. So you then need to have the wave go back the other way, so keeping the same rotational setting and the same feeder movement, you just then switch to left Y direction, and you get the next line which is identical to the first, except that the Y is going back in the other direction across the coil. Once you've got your commands, and you might add more if you're doing more waves per turn, or you could do multiple commands and do several turns, and that's one way of getting more precise laying down of the wire. Once you've got the commands created that you need for your script, all you have to do now is terminate the loop. So you go back to this screen, add finish loop, click on add command, and it will add your termination, and this just closes this loop and tells the scripting engine when to loop back to the start of the loop. And that's it, it's as simple as that. The difficult part, of course, is to figure out the angular rotation, and you can calculate that, but where it gets complicated is as the coil grows in size, so this value needs to change. So the way I tend to make bigger coils, and if we look at this image, you can see that there are 2 coils here. This was for a project I did some time ago. In fact, I sent this image to the manufacturer of this machine, and they put it on their website. This was for a project I worked on some time back, and I had to wind some fairly tall, narrow coils. One had 5,000 turns, one had 7,000 turns. And that was done with this machine, but because the coils were so tall, and the difference in the circumference between the starting point and the end point, as you can see, is huge. And so I had to do a script that was staged. It was very similar to this. The only thing that varied is I think it was every 500 turns. Then there was a new loop, so there was a first loop with 500 turns, and then the second loop had 500 turns, but it had a different angular rotation. It got smaller and smaller as the coil grew, and obviously that was to make sure that the wires were being laid down close to each other and the gaps between them weren't getting too big. If the gaps get too big, then the wires just all pull off the coil. And then it did that every 500 turns for the total coil. Okay, so as you can see, it's fairly simple. Again, I'll put the software in the corner of the screen, and we'll go back and look at the winding machine, and we'll run this job and see how it develops the coil. Okay, so I've laced up the machine. I've got the wire coming through. Now you can wind these with standard enamelled wire, but it's much easier using cotton covered wire like this. This is very expensive, but it does make a much better job. Now when you're doing these coils, normally you would have a small pot of lacquer and a small brush, and as it develops every layer or so while it's running, you just wipe some lacquer onto the surface of the coil. And if you use fast setting lacquer, then it supports the coil as it grows and it stops the whole thing falling apart. And again, being a cloth covered wire, it accepts the lacquer very easily and it makes a very nice job of the coil. I won't do that here, it's a bit messy and it will hide what I'm trying to show. But the wire's laced up, it comes through the adapter, down through the guide loop, and on the former to support the first few layers, or the first layer but the first few turns, I put some double-sided tape, and that will just hold the wire in place until the coil develops. If you don't do that, it can be very difficult to get the first layer to behave itself, and you end up with just a mess that keeps sliding around the former. So I'll do one loop as I've done here, stick the wire down to the double-sided tape, which is what I've done. Again, I don't know if you can see this on camera, and I can now start the machine up and you'll see how it creates the coil. It is quite slow. I think the 7,000 wind coil took something like 4 hours to wind, so I won't do the entire coil. I'll just do the first few layers, and I'll probably speed the video up, otherwise it will get a bit too tedious, but you'll see how the coil develops and how it's built up layer by layer. Okay, so you can see the coil is developing quite nicely. It's been laid down layer by layer. Each layer is moving round slightly further by slightly more than the diameter of the wire, so they're overlapping, and each successive turn holds down the previous ones, and then the whole structure when it's finished is quite firm. It won't easily pull apart. Normally at this point you'd start applying lacquer so that the coils won't start lifting off as it winds them. As I say, I won't do that because it would mask what I'm doing, but you can see the principle, and we're currently 150 turns in, and this would obviously just continue now to the end of the coil, but hopefully you can see how this works. So I'll just stop the machine, and it will just continue winding layer on layer until it's completed the entire coil. And the only downside with this sort of coil is you do need to set up the former correctly to start with, and it's very slow compared to standard linear coils. But having said that, this method can't really be done successfully by hand, and you really see the power of this technique when you get windings that are 30, 40 or 100 layers deep, and it is quite fascinating to watch. So hopefully that was of some interest. If there's anything else in particular you want me to demonstrate with this machine, then let me know. If you want more details about how to use it, then leave a comment. And so I have a few rewind jobs coming up that I need to do, so I will probably video a couple of those and post those so you can see some actual transformer and coil rewinds.